guys are looking for a little bit of direction, we can start with something like this. Get a section pull up.
Star text, right? Hey, Alex, with star text?
Yeah, the text file that's uploaded. It'll give you like a bit of functionality, so you can get to here, I guess.
Yeah. So I've just quickly thrown this together. The B being able to be controlled via the arrow keys. So if you move right, and he moves that way. Left, he goes that way. Up, down. So I got the actual rotation in there.
You can try to make him shoot or something. That'd be crazy. You could shoot other bees.
Yeah. So, I mean, if you guys have an idea of what you want to try putting in, and you're not sure what or how to go about it, just let's start spitballing. Let's work together as a team to figure this out. Is there any? Maybe we could try the shooting a projectile idea. Let's see how we make that work. So, if we wanted to make the bee shoot a projectile, what we'd have to do is come up with some sprite for that projectile. And then what I'm imagining is, we have some kind of shoot key, so I don't know, maybe space, we can come up with whatever key we want, but when we press it, the sprite for that projectile is instantaneously placed on our bee and then moves in direction going forward.
So the texture for the bee is already loaded. You just do a sprite B2.
So we have the
attached to the same bee.
We can have the bee shoot other
and when you hit space, you have a bee set up on the same coordinates. The coordinates of B.
Right.
And then travel, I don't know.
Yeah, let's have our bee shoot smaller bees.
Oh, you can scale him, this guy. It's in there.
So first things first, we'll need to create our smaller bee sprite. So I'll do that around where I have the first bee. I guess suppose, but real quick before I actually go into that, let me talk about the changes that I made. So all I did was, in my code here, was first of all I deleted the tree, because if you noticed, I didn't have the tree in there. I then set the bee to be on screen, because it starts off screen. And then I set the origin of the bee to be the center of the bee. So we've talked about in the past weeks how, all sprites and stuff are sort of anchored by their top left coordinate. But since I wanted the bee to rotate to face where it was going, I don't want it to rotate, like this, like sort of swing out like a panel. I want it to, flip in place. So I changed the origin of the bee, so instead of being the top left, I made it the center, so that's where the rotations occur. That's what that set origin line does. And it's one long line. I split it onto multiple lines, but this is where it would end up being. But all I did was set the origin to the bee's width divided by 2 and the bee's height divided by 2. So it's, the rotation point is now the center of the bee as opposed to the corner of the bee. I also added a variable for keep track of the bee direction, just so I can keep track of what direction to put the sprite. 0 up, 1 right, 2 down, 3 left. I just came up with that arbitrarily. Then in the actual looping, I have the code for moving the bee. So this is just the same movement code that we've seen before. So set the position to its previous x and its previous y minus 1 for this is up. Then right, it goes the x plus 1 for down, it's y plus 1 for left, x minus 1.
Yeah. On the Discord, there's a little picture up. I have a little white picture, and it shows like plus x right, minus x left.
Exactly.
So if you need a quick,
you'll get an intuition for it soon enough. And then I also set the b direction variable because right beneath that, that's where I actually control the sprite's rotation. So for up, so by default, the b sprite is facing just left. So we have our b sprite, the b's here with a little head like that. So if I wanted to make it face up, what I did was I rotated So that now is doing like that. So I just rotate it by 90 degrees. Then to make him face right, I change his rotation back to 0, but then I scale him with a -1 in the x. So in other words, he flips on the x direction. So no rotation, but flip on the x. And then combine the two to make him face down. Yeah.
Why are you doing both?
Because I wanted him to face up, or you can't.
But wouldn't set scale do that without the rotation?
It would just make him upside down. If I just did set scale on the y, it would be like this. He would just be an upside down B, not a facing up B. So you have to do some rotation, in this case, just a 90-degree rotation, so that the head actually goes that 90-degree angle. So it's either, he's normally facing this way. If I want up, that's just a 90-degree rotation. If I want to go right, that's just a flip. And then if I want to face down, it's a 90-degree rotation and then a flip. So that's how I do both.
And then it loaded, okay, and set scale is 1-1 automatically.
Yes.
Like,
So,
it's
well,
already 1-1 now. Aren't those the default?
yes. So it is 1-1 automatically, but I have to consider what if I'm changing direction.
Oh, changing back.
Yeah, so I'm
that's
changing
why.
back.
You're undoing it.
Yeah, so for example, if you look for the facing left, I'm setting rotation to 0 and setting scale back to the default.
Yeah.
And that is the default.
Yeah. Because you're at negative before, when you hit it, it goes back.
Exactly, I have to be able to turn that. So that's the only code that I've modified here. I just removed the tree, added the B direction, and gave it some movement. But now let's try getting our B to shoot smaller Bs. So first things first, we want a new B sprite. So we already have the texture B, so let's just create a second sprite. Create it right down here. So sprite, I don't know, B proj for projectile.
You have to declare the sprite object
Right.
first.
So yeah, like that. Sprite B proj for projectile. And then sprite B proj, texture. I'm just copying the process I have up here. Texture to texture B, not B, B. And then sprite B dot set position. I don't want the projectile. So the thing is, we want the projectile loaded in at all times, but we only want it visible when you shoot. So I'm going to start him off screen, and then I'll just, instead of, when you play games, you might normally think when you hit shoot, the bullet loads in and goes forward. But in reality, loading in takes time, and you don't want to hit the shoot button and have the computer spin for a second as it loads an image and then shoots. So instead, we're just going to store it off screen or out of frame so that we can just teleport it where it needs to go when we shoot. So I'm going to set his position where I know he will be off screen. So set position to -100, -100. Can't possibly be seeing that unless he was a giant sprite. Speaking of which, I think the B that our B shoots should be smaller than our original B, so I'm going to make it small. So sprite B proj dot scale, right? I want to set scale to the 1-1 would be normal size, so let's make him half the size. 0.5, 0.5. Okay. I think we're good. Although I think I want my B projectile to also face the direction he's traveling, like my bigger B. So I'm going to do all this process that I did up here for my new B, change the origin and give him a direction variable so I can keep track of that. So, sprite B proj dot.
Can you get all that stuff? Because then you could just do it.
Copy paste. There we go. And sprite B projectile instead of just regular sprite B. There we go. So now the B projectile has the same origin, and int proj, direction. So the projectile also has a direction. Make sense so far?
Nice.
I don't have like a guide that I'm going off of. I'm improvising this. So if you guys have questions, or if there's something else you'd like to see added, just let me know. Okay. So we now have our B projectile, and just to make sure you know, always test your code. I'm actually going to change his starting position to 100, 100, just so I can make sure he's loading in properly. So we should just have a tiny B at position 100, 100. I don't see him.
Is he behind the flag? Oh, you didn't even draw him.
I didn't draw him, yeah, good point. So, good thing we tested. Let's actually how to draw the dang base right. Alright, so let's put him, I want him to be beneath my other B so that, like, it looks like he's kind of being fired from him and doesn't just teleport on top of him. So we'll draw him first. Window.draw sprite B proj. Okay. Now I run it again. Now we should be able to see him.
So I guess he doesn't show up at the negative thing. So when you're setting position, he's still not loaded in. The drawing loads him onto it.
Yeah. I mean, he was loaded in, like, he existed, he just wasn't being drawn. So I guess that's another way you could control whether or not they're seen, is control whether or not they're drawn.
Huh.
You could have them
Throw
loaded
it in
in.
a if statement?
Yeah. The only thing you have to watch out for is even if they're not drawn, they're still physically in the world. If you have collision set up, they'll still have that set up. So you gotta watch out for that.
Oh.
So I'm gonna keep him off screen for now, just to, I'm gonna keep him off screen for now, just to be safe. So looks like he's loading in. Looks like that's a good B projectile. You guys reckon? We'll have a tiny little B projectile. So, okay. So now I'm gonna quickly go back and move him back over to -100, -100, so he doesn't start on screen. Now we have to set up a fire button that causes him to teleport onto my B, change his direction appropriately so he matches my firing B, and then have him travel in a straight line until, I don't know, maybe just a certain distance. We can make up the rules on that one. So let's start with the shoot button. Favorite keyboard key? Spacebar. Okay, so,
Mouse button 1.
let's see. So if keyboard door is key pressed, keyboard space. There you go, space. So if space is pressed, this is the shoot. So first things first, we have to teleport our sprite B onto our normal B. So let's try that first. Sprite B proj.set position, and we'll set his position to be our regular sprite B's position. Sprite B dot get position. And I don't think we even have to do the X and the Y separately. Yeah, it'll intelligently figure that out. So our B projectile's position is set to our bigger B's position. So notice this one's proj, this one's not proj. So let's just see if that works. Now if I press spacebar, the little B will teleport to my big B.
A bunch of them might appear actually.
Let's see, sorry. Looks like, yep. It looks like it works now. Remember my little B teleports underneath. I have it drawn first, but if I press space, he teleports to my big B. He's not moving yet, or rotating, but he does teleport.
Okay, you can make a little trail.
Yeah.
If you just increase the amount of bees on.
Yeah, we can make a snake. So if I go all the way over here and press space, boop, there he is. Okay, so far so good. Now we need him to move, and he should ideally move in the direction of the bigger B, right? Whatever direction the bigger B is facing, which I have a variable for that. So we will set, let's see, so.
Should you do it after the switch case? When do you check for B direction, right? Because you're going to copy the direction. from the
Yeah.
B to the
So,
projectile?
I suppose it only matters.
It'll go off the last frame then.
Yeah, it only matters if I fire and change direction on the exact same frame. If I don't, then it'll just feel natural.
Yeah.
So I think I'm not gonna worry about that. If it does come up, like if I test it, it's like, oh, that feels unnatural, I just gotta switch the 2 blocks of code. So I'll just put it up here for now. So, it was, what do I call it, B proj direction? I can remember my variable names.
Now you're.
Yeah, proj direction.
Attack.
Is 0.
Yeah.
So, proj direction gets B direction. So whatever direction the big B is going, I'm setting my small b to be the same. And only when fired, it's not going to constantly update, only when fired do they set. So let's say I fired a small b, he's traveling this way, and then as he's traveling, my bigger b starts going some other way. I don't want my projectile to suddenly move, like, maybe you want a remote controlled b, but
You can do it, yeah.
but I want to start with just a B firing in a straight line. So his direction is set only upon firing and stays in that direction until fired again. So that's the idea. So only set here. Now I do still want him to rotate, so I'm going to copy my whole direction control switch statement and set that. Make one for the projectile direction. Direction. And then instead of controlling my regular B, it'll be sprite, B, proj, and I'm just going to copy paste real quick. Copy, paste, copy, paste, copy.
This is starting to look like a function.
Yeah, I really probably should make a function.
Eventually.
I'm gonna push through as it is for now.
Eventually.
Okay, so that should control the direction that he's in. Okay, well let's test. Always test. Code a little, test a little. So he now should rotate to my big B's direction when I fire. So I move over here, I'm facing right, I fire, he's big. Because his scale doesn't get changed, I change his scale in the rotation. So
No, you copied it over.
Now I'm just leaving behind a shadow clone. Okay, yeah, so I need to, when I set the projectile scale, instead of using 1s, I need to use 0.5s. This would be great for a variable or a constant, but we're just going to push through.
Well, you can get scale, and then just add the negatives.
I could. But I've already made this change. So we're just going to push through. We could design this so much better for easier edits, but that's up to you guys.
There's so much to do.
Yeah, you guys can improve on my code. Okay, so now the little b, he's facing the direction that I'm facing when I fire. Okay, I think we're good. The only thing we need to add is the little b has to move, right? Move in the direction that being fired.
The little bee should have a laser.
the big b shoots a little b that shoots a laser. I mean, we certainly could do that.
Nice. You just leave the B in the position it's in, the little B, and just draw the laser out.
Yeah, so instead of a projectile, the little b's like a turret.
You could load in like text rectangles and whatever, and then you scale them, like out or whatever. So you could load in a little laser that grows out and make it red or whatever.
Force field early.
So
It's
I
doable.
think
You could add a force field.
I'm going to add the small b's movement just to the same switch statement as its direction control. So sprite b proj dot set position, and I'm going to set it to the projectile dot get position dot x, and then the same thing of y. And then if this is up, I want the y to go -1. Don't forget a semicolon. Okay. Now I can just copy and paste this line, but change which direction I'm moving. So this is for right. So instead of y -1, pop quiz. What do I need to do to make it move right? Plus 1 where? X. Yeah. X plus 1 is moving right. So this is going to be down. So what do I do for down? Yeah, y plus 1. And then process of elimination for left.
Oh no, so when you
-1 for the x.
if you don't have the library set up,
Okay.
you have to download it.
So now,
Open that.
well, that should change his position as he's moving, so now the bee little bee should fire.
Yeah.
That's-
Here, then.
There he goes.
Oh,
And he's independent of my larger bee, so I can fire again. So, there we go. Now, we could continue to improve upon this, because first of all, if I fire again before he's off screen, he just comes back. So if I just mash it, if I want multiple projectiles, I need to have multiple projectile lockouts. Also, if I'm all the way on one side of the screen and I fire, maybe there should be a distance, or maybe he does really just want to travel across the whole screen. Also, it doesn't feel right that I can keep up with my projectile. Let me make him faster. The projectile shoots twice as fast as I can move. I've decided. That's just coming up with the numbers myself. So change all these to 2s. There we go. There we go. There we go. Little bee fires nice and fast now.
Oh, nice.
Battles of the bees? Or, oh, it shoots out little bees.
Yeah.
Oh, okay.
Well, there you go. That's projectile. That wasn't too hard.
Nice.
So, now what?
And then we just add another graphic, if we wanna load in another image to that system. Okay.
Yeah. All you have to do is load in more sprites if you want more things.
If you wanna make the bee Super Saiyan, when you press a button, you could load in a little Super Saiyan thing that shows up beneath it.
Sure. Sky is the limit. In fact, the sky is not the limit. Watch. I'm gone. Go into space. Alright. Well, you guys ideas? Any other ideas you want to see done? There's no secret magic to like modern video games. It just starts with this, and you just, I want more than one projectile. You figure out how to do that. I want it so that the projectiles only go some distance before they despawn, so that you can't just shoot them across the screen. Do that. I want obstacles that I can run into. Do that. I want the projectiles to stop when they hit the obstacles, or to break the obstacles, and you do that. You just learn the little techniques. How about? How about the bee, if the bee shoots one of the clouds only if or at least gets reset. We'll also make the clouds faster. So here's the cloud code. I haven't changed this yet. I'm going to.
Cloud explodes when bee touches
Nice. Yes.
There's,
Do you have the book file?
Yeah.
probably somewhere.
Cause they're on the thing. Chapter 7 has the collision code that you can copy out unless you want to look for it.
You have to take that class already, right?
Let's see, how do I?
No.
There's like a
Got it. So run this.
That's all I don't like. Reasoning and logic.
Now the cloud speed is set. Yeah, it's easy to tell.
This t-shirt is from ARCS t-shirt. Shut up.
There we go. Much better moving targets. Now we actually have to make sure, I have to figure out how to make
Yeah.
with,
For sure.
Yeah, what we wanna do is check
Right.
if the projectile has collided with the clouds.
Yeah.
So,
So-
sprite b proj dot get
Global, yeah, that one, then dot intersect.
intersects.
Yeah, now inside that, you do the same thing for the cloud global bound.
Well,
So I guess you'd have to do 1, 2, and 3, you know?
sprite cloud, yes. You have to check all three separately, yes. Sprite cloud one dot get global bounds. Okay. So that is my condition, so if I put that in an if that, then that means the B projectile and cloud one have collided. Let's just do cloud one for now. So if they've collided, what do I do with cloud one?
You can send the cloud off screen.
Yeah, I think let's see. I think what I will do is, I think this code should already handle the cloud active stuff. So if I just set cloud one active to false, maybe that would just handle it. Let's see how that works.
Next frame will reset it.
So, yeah, that's what I'm hoping. Let's just see if that works. If the B projectile collides with cloud one active gets false, and we'll see if the existing cloud active code does anything. Now I will have to try shooting them all, because I don't know which one's cloud one.
What again?
Nope. That one.
Oh.
Okay, it kinda works. Just kinda resets to the side of the screen.
You're bullying that cloud.
And perhaps the cloud should teleport a little bit further off screen.
What if you have the cloud push back to B, so if the cloud touches you, you get pushed back?
I suppose, yeah, right now it doesn't touch me. Okay, so it looks like the existing active and active code.
Bro, it's coming together.
Works.
50 points, high score so far.
You could, every time you hit, do a score display, and every time it hits the tree and resets it to false, you can just go score plus plus, and we'll start counting it up.
Let's see, so, what is the position?
Yeah, pull the code.
Since it's negative 200, I want to start a little bit further, so let's go 4.
Yeah, open the code folder.
So that when I shoot the cloud, it goes
All of
properly on
these.
screen.
Into Visual Studio, and then they'll all appear here.
And now it's like this.
Destroy, the main toss.
Okay, so that works. Let's add that to remaining clouds. So I'm gonna make sure they all teleport off screen with a 400. And then I have to copy and paste my
You wanna
collision.
to see what's under views, solution
The only thing I have to change is change it to cloud 2, and
So drag
3,
it under me,
and then here,
and then you're gonna delete me.
and 3. Alright, should now be able to shoot all 3 clouds.
We could also do this. We could link
Okay,
it,
so
so
far so
the
good.
original actually works.
Now, it feels
Yeah.
kind of bad that my projectile plows straight through the clouds. So maybe upon hitting the cloud, my projectile also disappears. So that I have to shoot every cloud individually. So, in addition to the cloud one active being false, let's set sprite b proj set position back to that negative 100, negative 100, so that it effectively teleports off screen once it actually collides. The only thing is, I'm afraid that my B projectile is going to be traveling even while it's off screen, because I never told him to stop. He's always moving. So maybe what I need to do is set my projectile itself to have an active in it. If he's not active, then he's not moving. So when I teleport him off screen, he doesn't just suddenly come back on screen on his own. I don't want that to happen. So let's actually fix that real quick. So sprite B projectile, very valid direction. Let's make it.
You just have to link the libraries, which is like a commonish thing, I guess, when you're loading.
You know what, I think I might cheat a little bit. If all my projectile directions code is handled by, it's direction variable, which can be 0, 1, 2, or 3 to change its direction and its movement.
Yeah.
So what if I set it to some value other than 0, 1, 2, or 3? You can't move, right? So if my projectile's direction is set to, let's say, 5, that's effectively making him inactive. I think that should be okay. Or 4, I guess. It's 0, 1, 2, 3, 4. So I think that's what I'm doing. So if my sprite B interacts with the cloud, then I set my, oh gosh, what was it, proj direction? Yeah, proj direction to 4. So he's off screen and no longer in his moving code. And I'll do that for all 3 of these clouds.
Yeah.
There we go.
You should get that one.
So now I should have to shoot each cloud individually. There we go. That looks pretty good. Of course, the clouds are only appearing at the top of the screen, so it's kind of like shooting fish in a barrel. But we got something.
Nice. Can we do the cloud pushback? I feel that the clouds are being oppressed.
Sure. So the clouds push my B around.
Push your actual B
Okay.
back.
Wow. And you think pushing them back is better?
Yeah, the B killing them a little
So
bit.
by pushing back, do you mean like they just?
So so if you intersect -1 from the B, so like you can't cross past the thing and get pushed back. So when you shoot the cloud, it sort of looks like it's being pushed back,
Right.
right? Because it's resetting so quickly. But you could have the B get pushed by the clouds.
Okay. So let's see, how do we do that? So we have to check for RB's collision with the clouds. If RB is colliding with the clouds, then I guess our B is moved by the amount of the clouds?
You could check, I guess, if the cloud is above or below you. And if it's above, yeah, you could check if it's above, below, left, or right, right? You could separate it into 4 quadrants.
Yeah. So it would be pretty easy to just say, I can't move into the clouds. That's a pretty easy check.
Yeah.
But having the clouds movement actually affect my B, that's a bit harder. Let's see, how do we do that? So if we just wanted to make it so that I can't move into the clouds like they're a solid object, that's not too hard.
Yeah.
All we have to do is check, before I move, would moving put me into contact with the clouds? If true, don't move. So, you know, if you're about to move, like, it's exactly the same as real life. I can move easily, but, right as I'm about to move, I make contact with the wall, or with the whiteboard.
What happens if the cloud moves?
So the original model.
That's a challenge, to figure out how that happens.
Do you have it push out, or is it just?
Yeah, does the cloud move the B, or does maybe, I mean, I suppose, maybe it's a bit of a cop-out, but the easy solution would be to say, oh, we die and there's the cloud, because then you could just teleport right there.
Push the B down and touches the cloud.
Yeah, just force the B downward. Let's see, how do we do this? So maybe,
These are I'll put together instructions for making
let's say if one of the clouds touches
and you'll be able to open
my
it, link
knee.
it, and it'll just work. You won't have to drag it anywhere.
Let's say if one of the clouds is,
Like anytime you're making a meal,
So it
which I was
pushes the
doing,
B right,
and
and
you'll be able
if
to
the B
work it out.
touches the end of the wall, like the right end of the wall, then the B dies.
we get squished. Sure. Let's say the clouds are like moving obstacles that try to push the B to the right.
So, again, my, if cloud position is higher than B position and cloud, position, if cloud position X is greater than B and cloud position Y is greater than B, push B back towards whatever. But then it's like kinda convoluted.
So what we could do is if we just want the clouds to push the B to the right, we could check,
What you can do intersects with the part B.
yeah, we could say, okay, perform all movement first.
We could have the cloud push the B down, and then you sort of try and get past it, maybe, and then you load in a bunch of clouds.
Let's see, I think what we can do is, I think it's a two-part process. First of all, the B needs to be prevented from moving into the cloud. The cloud is a solid object. Secondly, if we perform all movement, the B moves, the cloud moves. And then at the end of the frame, if the cloud has moved onto the B, push the B out as if, so that, we handle the B's movement first, then we handle the cloud's movement, and if they're overlapping, then the B should instead get pushed. And we handle that after all movement, so that, the cloud's movement happens first. So, first things first, let's prevent the B from moving into the clouds. Let's start with that. So in order to do that, we go up to our B movement code, and if we want to move, but it would put us into a cloud, we don't move. So we have to have some way of testing, if we collided with a cloud, cancel the movement. Is there a way of checking? So let's say, in this case we're pressing up. We've changed the B's position to be up. Then if we collide, I'm going to go copy my collide code. If all this clears the code. So if, not my projectile, but the B itself. So the B moves. If, after moving, the B has collided with the cloud, undo the movement. So I'm going to take my set position and just reverse it. So technically the B tried to move into the cloud and then was reversed, all within a single frame, so it won't look like the B's jittering, because this all happens before it's even drawn. So I think that's the idea. And then, so the B cannot move into the cloud. So I think, I'll just try it with up first. So it won't work for left, right, or down, but at least for now, I should not be able to move up into the clouds. And also the clouds are not going to push me yet. So if I just try moving up into a cloud, it looks like I stopped dead. I'm holding up, and now I'm free. So it only works for up, but it looks like it's working, right? So the B cannot move, well, I only did for cloud 1, whoops. So I got to do it for clouds 2 and 3. Maybe this is the time to put things in an array. I'm gonna remain lazy. So let's see. If I try to move up, and that position would have collided me with cloud 1 or cloud 2 or cloud 3. So if I've collided with any clouds, now I should be prevented from moving. Alright, make sure it works. Now it won't just be one arbitrary cloud. I should be forcibly stopped by all of them. Well, they're all on top of each other, I guess it's not too useful.
Shoot them.
Yeah, I guess I could, yeah. So that one, and then that stops me, okay? So it looks like it works for up. So I should be able to just quickly modify this for, left, right, and down. So take this if statement. If I try to move right into a cloud, and I intersect with a cloud, undo the movement. So the right movement is +1, so do a -1. If I try to do down, same thing. I undo the movement. Down is a +1 on the Y, so I do a -1 on the Y. And then this one, it's a -1 on the X, so it's a +1 on the X. +1 on the Y. Okay. So now, theoretically, my B should not be able to move into any clouds. If moving into a cloud, If it attempts to move into a cloud, it is stopped. So up still works, try right. I can sort of follow along, but I can't move actually into it. Now, this direction is a bit awkward because the cloud can still move into me. And once I'm in the middle of the cloud, I'm kind of stuck. I can't move down either. So it's working, except for the cloud pushing me part. Right now the cloud just overrides me. Well, so far so good. Now we need to do the cloud pushing part. So I think what we'll do there is, after the cloud has moved, so just like we did for the bee, the bee moves, then we check if there was a problem. Same thing for the cloud. If the cloud moves, and if the bee is now overlapping it, instead of undoing the cloud's movement, we'll just push the bee. We'll move the bee the same distance as the cloud. So, and here. So, here's where the cloud moves. It's the delta time. So, if the cloud has moved, so the cloud changes position, then if, there we go. I don't need all of this though, I only need to check for cloud 1 and B. So just a single condition here. If sprite B intersects cloud 1, what I want to do is change the B's position to, I want the B to move exactly as the cloud moves.
That'd be plus cloud 1 speed times delta.
Yep, exactly. So I'm going to take the exact code that's being used for the cloud's movement. There. Already I can feel like this would be better served as a function where we could do it for any arbitrary movement. For now it's only going to work for pushing
You
right.
can just get the position. You don't even have to. You just go cloud position plus, and then they'll push it back down.
I could. Let's see.
If that's correct.
Let's
I'm
see if
not
this
sure what
works. I'm just kind of improvising here. Let's see. All I've done is, after the cloud moves, if the B overrides the cloud, push the B to the right the same amount as the cloud is moving. So let's see if that works. And it's only going to work for cloud 1, so clouds 2 and 3 will still go straight through me. Okay, I'm not doing that. Now it is just going to push me off screen at the moment because there's no. Right. It only works with one cloud, but it looks like it is in fact pushing me. So that's pretty good. Now let's see if this cloud 1. Yeah, so I'm trying to move right into the cloud there, and it's still not letting me. So it's still solid.
Can we lift the pushback more? So that way the B will like pop back on collision?
It could. I kind of like how it just slides the
carries
B
it.
over. Yeah. I
It's
suppose
actually, if
what
it pops
we're
it
creating
back-
here is some sort of dodging game. Like right now the clouds are only at the top, but I can theoretically make them be all over the screen much faster, so I have to not be pushed around. Let's before we go too far, let's make sure we take this code and make it the same for the 2 other clouds. So cloud 2, we check for cloud 2, and move it by the same speed as cloud 2. And then cloud 3, we move it by cloud 3, and we check for cloud 3. So I think this will be fine. Now all the clouds should push me back. Now the clouds just are like solid objects that the B cannot interact with except by shooting them. Ha. Alright, well now to make this more of a game, let's try and modify the cloud code so that they actually, well, for 1, move a bit faster so that they're an actual obstacle, and for 2, appear all over the screen. So cloud speed is kind of randomized. Let's say, let's increase the range. So instead of, right now this is 200 to 400. So let's go 100, how do I change it so where they're mod? Okay, so this is the cloud height, 0 to 149. So instead of being just position height 0 to 149, let's make it the whole screen size. So random modulo, oh gosh, how do we get the screen height? I haven't done that yet. Well, I know it's 1080, but is there a more?
I want to say you can do window dot something, right? Because that's the actual window.
Window dot.
Get.
It's.
Should be a get.
Get position and size.
There you go.
Get
You
size.
could maybe dot
dot
yeah.
one. Okay. So.
Easy peasy. Divided by or.
I think it should be fine. Because it's going to randomly, it's going to be between 0 and the window height. I think this is fine. Let's try setting it for all 3 clouds. So that was cloud 1, so cloud 2. Oh, the clouds have different heights. So let me make them all just the window height. And then cloud 3. Okay. Now they appear all on the screen. Okay, that's better. I might need to add more clouds. So they definitely, okay, yeah, so they can appear all the way up here and all the way down there. So that looks like the whole screen. For how sparse they are, I might need to make them faster. Or bigger, or maybe make more of them.
We could make it bigger. That's just a scale, huh? You just scale them up to 2 and increase the speed. Make them a bit more messy.
Yeah, I could just make them bigger and faster.
Or even stronger.
So let's see. So make them faster. I'm already, let's say, 400 to 700. So I'm already feeling the hurt for not making all these constants. That's up to you guys to make this better design. If you can think of a way to make this better designed, go for it.
How would you go about optimizing this?
Yeah, that too. Alright, so now they're definitely a good chunk faster.
No optimization, more features.
Let's make them a bit bigger.
Put more features.
So to make them bigger, I don't think that's too hard. Just at the very beginning when you just change their scale, like when they're first loaded in. So let's say sprite cloud 1 set scale to 2. And I'll copy that for 2 and 3. 2, 3. Now they're double size clouds. Fast and large, but still destroyed by a single beam. Oh, definitely bigger. I spawned inside of that one. And I think I need to teleport them further off screen again. Now when they reset they were being teleported just off screen. So now that they're bigger, we can see the actual teleportation.
Bro, this is crazy.
So let me modify that a little bit.
Look how far.
When the cloud is, it's up here. No, it's down here. When the cloud is set to be inactive. Here, okay, so it's -400. Let's change it to -800. So now they'll teleport far off the side of the screen.
Yeah.
There we go.
Can we leave one of the clouds, give them some personality? You'll have one special cloud.
Sure. Let's make Let's see, what's your favorite cloud? 1, 2, or 3?
Come on, 2, give them like a
2,
lead.
okay. Sprite cloud 2 dot set rotation. Actually, I think I just say rotate. Rotate by, let's say, 10 degrees. Just slight.
Yeah, ever so slightly.
Ever so slight.
How do you see that anyway?
Oh, I think he's
There he is,
looking
he's
along
right there, you can see
there.
him.
There you go. there's, it definitely makes his hitbox a bit wonky, but he's a little.
You got a mean one in there.
Yeah. Where'd he go? He didn't come across that time. There it is. Are they overlapping? I think sometimes they can appear off screen. Okay, well, I guess the next step is to swish. So, if we want the bee to swish, we should probably prevent him from going off screen overall. Or her, I'll use her bee. So, yeah, I guess we should prevent the bee from going off screen. So, let's start by preventing the bee from going off screen, and then we can check to see if the bee is pushed off screen. So, just like before, when we tried to move the bee into the clouds, we prevented it. We can also check to see if the bee is trying to move off screen, and if so, prevent it. So, let's say if the bee is moving up, we can use the exact same check. If the bee is trying to move up and it collides with cloud 1, cloud 2, cloud 3, or the edge of the screen, don't move. So, or trick is finding the edge of the screen. Sprite b dot get position dot y is 0. Not as hard as I thought. The sprite's y position is 0. In fact, let me say less than or equal to 0. So if we try to move the bee up too far, and its y position goes less than or equal to 0, don't move. Or rather, undo the movement. So now at the top of the screen should be a barrier. Well, sort of. So the issue is that it's calculating it based on my origin, which is the center of my bee. So half my bee can still be off screen. So it kind of works, but if we
Well,
want,
you could add the size of it, right?
yeah, we might want to change the change it so that our bee. So it's less than 0, or rather,
Maybe like 2.
it's less than half of the width of our bee. So sprite b dot get size, get local bounds. That's what we want. Get local bounds dot y divided by 2. Something like that. Dot local bounds. Oh, it's height. From the local bounds, it's actually height, not x and y.
Yeah. Height and
So if my
it
y
also
position,
gives you it actually gives you top and left too as well, I think. So you can do top.
oh, in that
No, that'll be like the point.
Well, hold on. So well then instead of checking my position, which is based on my origin, let me just check the local bounds of my top. So hold on, that makes it easier. Hold on. So sprite b dot get local bounds dot top. There we go. If the top of my b is less than or equal to 0, there we go. Wait, I don't think that's going to work. Now that I think about it, I want global bounds, not global
Yeah,
bounds.
because I was thinking that too.
Okay, now I'm just prevented from traveling up at all. Okay, so that's not gonna work. So get global bounds. Global bounds. So we get the global bounds. So that's our bee's position in the global world.
The top of our B.
And
is
the top of our bee is.
I wonder
less
what our
than-
global position is based on. When you rotate it, does the top change?
Good question. Should be able to tell here. Looks like no. I am prevented from moving off screen.
That looks pretty good.
Alright, I just gotta, oh, new question. And I just gotta do that the same for, left and right and down. Okay, so if I'm moving right and I encounter a cloud, or my global bounds dot right, is that
1080,
an option?
1920.
Width, I have width, I don't think I have right. I have
Global bounds should have, it's, you do left plus width.
left plus width, yeah, there you go. So left plus,
Yeah, it's kind of weird, like,
that's C++ for you.
well, no, I guess what global bound return is left top width height. Those are the four in there, those are the four variables.
So we got left plus width, so that's our right. And if that's greater than the width of the screen, which is screen, what was it? Was it screen?
Screen is 1079, no, 1920, 1919?
What was the variable that we used before?
Window.get size y, or we just saw it.
Window.get size dot x.
Also, there's a way to pull native resolution and just plug it in, so that way the screen will match every time to whatever computer,
Yeah.
if we care.
Okay, so that's to the right. So now I should be prevented from moving to the right, assuming the clouds don't push me. So, okay, that's good.
Can we have it like, if you get squished to the right by a cloud, you die?
Yeah, that's what we're gonna do. But
Or
for
we're
now.
He's gone.
Okay, so let me finish the rest of the collision for the sides of the screen, and then we'll actually do the squishing bit. So, so this is left, I'm sorry, this is down. So I want, so I want get global bounds dot top plus get global down. Gosh, these automatic window little pop-ups, I want to highlight the thing underneath this window. Come on, please.
Get pranked.
Is greater than window.get size y, okay. And then once more for left. Oops. So if my get go bounds on left, I just have to check left is less than or equal to 0. We're just looking at left. Left and up are easy. Okay, so now all four sides of the screen should be a variable. We're doing it. We're making a game. It's coming along here. Top, left. Oh, I think my window's just not on the screen. Hold on. I can't go full screen. Well, so I think it is stopping me down there because I'm holding down, and I don't think I'm going any further than down there. It's just that it's below my start bar. I'm not going to worry about that. And then right. Okay. So now all we need to do is check to see if the cloud pushes us off screen. So I think the way we can do that is, right now, the bee's movement is prevented first. So the bees can't get pushed to the right. After that, the cloud's movement occurs and potentially pushes the bee. So after that, I should check if the bee has been pushed off screen. The order of operations is important.
Pushed off, but a bee can't be pushed off screen. So are you checking if the bee has touched the edge of the screen?
Well, the bee can be pushed off screen at the moment because the cloud pushes.
Oh, the bee can't go past the screen. The cloud can push the bee.
Yeah, I can't willingly move off screen, but the cloud should be able to just, there we go, just willingly take me straight off screen, and then I'm kind of, let's me come back. But instead of just letting me come back, it should squish me so that I can't. Okay. So after the cloud's movement has occurred, all three clouds get to go, and then the last thing we'll do is check if the bee's position is no longer on screen. The only way that can occur, because I start in the middle of the screen and I'm not allowed to move out of frame. So the only way I can be out of frame at this point in the code is if the clouds push me. So that's what I'm checking for. So if right b dot get global bounds, global bounds dot left, and then plus right b dot get global bounds dot width. So my left plus width, so my actual right side is greater than or equal to the window dot get size dot x. So I checked for this before and prevented it, but if it still has occurred, that means I've been pushed off screen. So this is where B is squished. So how do we actually handle the B squishing part? Presumably we should like right make it flat.
I wanna say, in the, I don't know if you wanna bother loading in the rest in peace sprites, cause it's in the folder.
I suppose we could.
You could replace the B with a little tombstone.
We could. Yeah, we just replace the B with a little tombstone with the right game over across the middle of the screen.
You'd have to load in other stuff though, you'd have to load in the text font thing
Yeah.
to do the game over part. Cause you needed a font, yeah, you need a font. But you can copy all that code out of the book files. The book files are on the Discord.
Right. Let's see. What do you guys think?
Or we just make the B go off screen. You could do like a quick spin in place. You could make it do a rotation, like a wacky.
Like a little Mario guy.
Yeah, if you load in the sound. But you could make it do a full 360 or one or two, like two 360s.
Fall at its back.
I guess so, yeah.
You could do like a plus minus 2 rotation for a couple of frames or whatever, and then go off screen.
Yeah, we could do something like that. What kind of death effects do you guys think would be best?
G, delay, you know?
That might be hard. Not impossible, but hard.
It grows so big that it covers the full screen.
The B just grows large. How about?
Or like it drops all its toys like Sonic.
Let's say. I think it would be pretty easy to just make the bee draw like on its back, like belly up like a goldfish. So all we have to do is, so that'd be, I just have to draw it so that it does this rotation, right? So I've done all the other rotations, I just to make it so that it goes belly up. So that'd be sprite B dot set rotation. I want it to set rotation 0, and then sprite B dot set scale to 1, -1. I think that'll just make him so it won't be visible for very long because it'll continue to push the B, but it should very briefly make the B appear on his back. Okay.
Nice.
Perhaps, I think what we need now is a variable to keep track of if the B is alive. And if the B is alive, do everything that we've been doing, but if it's not alive, prevent user input and prevent the mouse from pushing. So we just, we're stuck on the death screen.
You can create another B in place of it. That doesn't have all the switching.
Let's see. If I just say rule be alive, so it's true. And then all I have to do is, all this keyboard stuff, just check and be alive. And be alive. All these checks just mean to check if the B is alive. If the B is not alive, don't bother doing anything. Ignore input and be alive. And be alive. Let's also prevent the B from shooting all dead. Let's see, and then, and we also want to prevent the clouds from pushing the bee, which is here. So if the bee clouds intersect the bee and be alive. So the clouds only push the bee while the bee is alive. And be alive. And then here, first thing we'll do is be alive, yes, false. So now the game will kind of just stop once the bee gets squished, and it'll just be belly up. Oh, good question. Alright, very simple death animation there, but it does the job.
Pretty cool.
And I am prevented from doing anything else now. So.
You can have, press enter, makes it active, puts it off, or whatever.
Say that again?
If you press enter, it'll put the B back in the middle of the screen, control.
Sure, yeah. Enter to reset.
To make B active.
So let's do that. So
So I just pop you back up.
back here where I'm checking for all the keyboard inputs. If keyboard is pressed, keyboard so if, let's see, should enter reset the game always or only after B dies? It's a pretty easy check. All we have to do is say if
B active is false.
yeah, if be alive is false or not. So let's just say enter always resets the game even if B is already alive. So if enter is pressed, sprite B dot set position to what should we start? Should I just set it to start by 200, 200? Yeah. I'll just reset it to a starting position. 200, 200. Be alive gets true again. And then let me also fix his rotation. Actually, I don't know if I need to fix his rotation. I think once he's alive.
Well, he's gonna be upside down now.
Yeah.
Well, as soon as you hit any keys, he'll correct it.
Yeah, he'll correct himself as soon as I press him.
So it doesn't matter.
Let's
Think you're good to
fix
go.
it anyway. Set. I think I like to do is set scale. So right, B dot set scale to 1. I think that should be fine. So if I on the screen, if I hit enter, okay. So it's a reset. That includes if he's dead, I'm back. Alright. Very simplistic, no flash
Crazy.
effects. Now I can shoot the clouds. Oh no, he's gonna get me. Squish.
Very nice.
There we go, we got like a game.
We did it. If you wanted to copy paste that into a text file and upload it in Discord,
Sure.
we could have this.
Please.
The only issue with the entry code is if it teleports me onto a cloud, I'm just gonna stuck in it.
And you die. That should just kill you. It should have that.
I'm trapped in the cloud. Let me out.
Keep going. It was the leader too. He knew. See?
So, I mean, this is very simplistic, but I mean, we're not too far off from like a running game, like, make it so the cloud, there's maybe more clouds that move a bit faster, so it's easy. Keep track of the score, like
You
every
can
time the
load
cloud
in
gets
another
shot.
cloud every 30 seconds.
Yeah.
Right? So, but then you should make the cloud smaller because these will be over.
And then maybe add another projectile to the bead, or, I don't know, keep the bee a bomb, I don't know.
If you have power-ups
Yeah,
spawn in.
spawn.
How would you add, or how would you make it so that like you said earlier, you can have like multiple bees shooting out?
So multiple projectiles? What I would probably do is I would make an array of projectiles. So
Yeah.
an array is maybe a bit advanced, I don't know what level you're at. But I'd probably still set a maximum. I'd say, you know, I don't know, maybe you want to have, like, if you just mash the button, you just get hundreds of bees coming out. But my gut instinct is like, maybe there's a maximum.
Yeah.
You can only have 3 active at a time.
You can go high, you can go 10.
Yeah, you can go 10. I
You
mean,
wanna like go full on, you know,
Yeah,
those
those
little
seven
things. Yeah.
So I mean, yeah, you could. So
How
what I
many
probably
pieces
do-
does it take to cover the screen or whatever? From one end to the other?
So what I would probably do is I'd have a set of these, and I'd keep track of which ones are active and inactive. Because they're all identical, so it doesn't matter which one is being shot, as long as you're only shooting the ones that are inactive. So, like, I'd say, you know, make a list of, you know, 10 or 3 or however many, and say, okay, you know, if no bee projectile is being shot, just shoot the first one. And you would say what you had before. But if the first one's already in motion, it'll check for that, you know, bee projectile traffic or something like that. And if so, shoot bee projectile number 2, teleport that one and have it move, so that they're independent. Like, you shoot once and you turn it another time. And then you do a third time. And then you either, you know, maybe when you hit the maximum, then it wraps around and deletes a bee, or maybe when you hit the maximum, you prevent shooting. Like, if no bee shot's active, pressing spacebar does nothing. So it's up to you.
Yeah, until the bees are out of bounds and reset to your,
So-
then you can do like a clip of 10 bees.
Yeah, so, yeah, you can reload your bees. So, but yeah,
The
you,
bees go out of bounds, they'll reload.
yeah, so you have, yeah, so you check if, right now, at the moment, my bee projectile is actually not very smart. If I shoot it up like that, it's still technically traveling up there, like going up into negative infinity and Y. Perhaps it would be smarter, you know, check if it's off screen, set it inactive, and
Get global bounds.
then the shoot code can check, is inactive, is not inactive, and shoot only the inactive ones, right? So that's what I would do. Yeah, and then I
Couple of
probably.
functions, couple of formulas.
Yeah, it's definitely, right now, it's very messy code in the sense like I don't have the functions.
But it's all readable. This is the fun part, right? Just figuring out what does what. You see it so quick.
Yeah,
Oh,
it's,
scale, rotation, bound, local, global.
yeah,
pop.
all the, yeah, we've already really covered all of the tools that you'll need from SFML. Like, maybe you'll need to look up a few extra functions along the way, but in terms of making the game more complex and adding features and making the code more readable, that's just all the techniques that you've learned in a regular computer science course. You know, functions, arrays, what have you. So,
Yeah,
then
and then-
your own coding skill is, where it comes into play, you know, if you, even if you don't know, again, I don't know what level you're at, but if you're, you know, if you're like, I wanna know how to do this, but I don't know how to do this thing of programming, that's where you learn how to do the thing of programming.
Yeah, you go back a step.
So there's no magic touch to modern video games. They're just, you know, this, but with 3D models. That is the magic touch, 3D models. But like the actual code behind them is, you know, it's if statements. If statements and numbers.
Just the for you.
Exactly. So, yeah, I'd say if I were to add more on this, my next step would probably be to figure out how to draw text on screen. Because then I can do that for 2 reasons. One, the game over text. You know, B dies, it displays game over. And then 2, I can write the score in the corner. Then I can keep track of the score. You know, every cloud shot is 1. Or maybe it's just a survival game. Maybe it's counting up maybe it's counting up how long do you survive. Then we make an increase in difficulty over time. More clouds, faster speed, that kind of thing. Maybe it starts with a few small clouds, and as it goes on, the clouds get faster and bigger, and maybe there's more of them. Until the point where it's like, you can't just shoot them all away. You have to dodge. And, oh no, it's hard, that kind of thing.
Yeah, you could also build like a top-down little maze thing, like a kind of like a Zelda thing right now. With just what we have currently, right?
Basically,
Collision, you could make little monsters like.
Just add a number to keep track of health. So instead of just being pushed by a cloud, you take damage and then maybe get knocked back a little bit. And then, you know, if your health is 0, then the thing goes belly up and you get the game on screen.
Easy peasy.
Yeah. And of course, you don't have to make a game about bees and clouds. just using what was available here.
That's the best way to do it.
And it's all just temporary. Like, if I wanted to make these different things, like I just have to literally change the sprite being used. So maybe instead of bees and clouds, like maybe the obvious choice is spaceship and meteors, that kind of thing. Just change the sprite being used. So instead of, I mean, it would be a bit weird because the code would still call all the variables bees, but like, it would still work. A variable name is just a variable name. It doesn't impact the code.
Nice, we blade.
Just take some experimentation. The only advantage I have over all of you is I've taken all the computer science courses. I'm not a game developer. I'm just making this up as I go along.
I'm trying a zombie game, so we'll see if I
Nice.
crack it.
Yeah.
Nice.
Yeah, take a look at those other projects. I can see what
Yeah.
the default stuff has already shown you.
The zombie game it shows you how to use the mouse coordination stuff, how it pulls it, it lets you rotate the guy. It uses like a fun little format, I forget, it's like, it pulls the mouse position, and then it does something and divides it by pi.
Yeah, it's
to get you rotation.
kind of
It's like
trigonometry.
online though, it's pretty impressive.
Yeah.
And then there's like a nested for loop that does the auto map generation. And then fills randomly the blocks inside, and then there's an if statement that goes, hey, if it's 0 for these walls, these are walls, if it's 0, and these are walls, if it's max. So, pretty nice, pretty nice. I have yet to make it past the zombie game in the book, so I'm working on that now.
I'm gonna try to remove the mouse function and just make it all keyboard.
Cool.
Yeah. No, you can just have if left press, if right key press, rotate.
Yeah. You have the character rotates to the direction that they're.
Is it
Like-
possible to set a frame cap on this?
Possibly. I don't know the technique because again, I'm no game developer, but I mean, this isn't for our class. Google it. Ask ChatGPT. Like.
You can do it right now. All you have to do is load in that texture stuff, and then every frame you could have a count.
Yeah.
Like
so,
that's divided by whatever. So
yeah.
once
So
you
the clouds are already being controlled by the frame, the delta time. My B is not. I just did constant. So it's sort of, I guess it's sort of half frame capped. But yeah, you just have to look up the technique. I mean, as long as you
Yeah, I don't think there's a frame cap. It's just like you get max frames until the game starts to get convoluted and slows down. But you could literally have it display frames. You just keep adding up delta time until you hit a minute, and then show how many additions there were.
I don't have a lot of time to make tons of modifications, but anything quick you guys want to see? Is there like a way to set color, like to tint a sprite?
Probably. I think there's a way to invert the colors.
Because if there is, we can like turn the bee red when it dies or something.
No, I think this is great. I think people can think about this. It will be great.
What have we got?
Looking
Get
good.
texture, origin, oh, set color. There you go. Set color. Set the global color for sprite. It's modulated with the sprite's texture. Okay, so let's see. I need a color. So if I just say we need color red. There you go. Okay, bee dies, turns red. Let's see if that works. There you go. And then just to make sure, when the bee comes back alive, we gotta make sure it turns back. So where's the enter key? Way up here. Here you go. No, that's space. There you go. Keyword enter. So it said the default was white. So sprite b dot set color white. Now if I hit enter, it shouldn't turn him white. He's white. it's adding the color to his sprite,
Like a
so.
tint,
Yeah, it's
maybe?
white, it uses this is white by default.
Could be,
Get in front of the cloud now. Okay, another cloud please, here. So, switch B, swish, and if I hit enter, I'm back to my normal color. There we go.
my God.
There. There's the blood. Do bees have red blood? I don't know. Alright, well I suppose I will, I guess, share this text.
Yeah, toss it out, I'll be ready. We can look at this next semester. And we'll be like, wow, look at all this, dude, this is great.
Really? Oh, dang, Alex.
Remember when we did that? That'd be so fire, dude. I'm actually excited when we pull this up.
Oh, man, I'm ready to get you guys out in the, quad to work on your
That's,
social skills.
What do you mean?
where do you want me to post it?
I'm gonna take that.
Maybe the, here, this,
Well, we
We
gotta
got
hit
a great bow, what are you guys talking about?
can I post here? I can't post here.
Does it let you go?
You should be able to just throw it in getting started for the other ones.
Let's see, which channel you want me to throw it in?
If you scroll up and getting started, it was right there.
Can I throw it in here?
I think,
Or click on the post?
yeah, it's the top left.
I'm not, oh, there we go.
Oh, there you go.
Okay, new post, B shoot,
You wanna put the date too,
Wow.
3/7.
clouds game, so, I can't type it out.
It's the plus on the top right
This
there.
one, okay. Find it, that's not right. I think it's up in my downloads folder. Not responsible for my files.
Maybe just put me in, yeah. I don't know why they're not doing that.
Okay, and files, enter message, this is the, sample game that we made during the 3/7 meeting.
Exclamation point in there,
Shoot
you already had it.
clouds. Okay,
And just post it,
Yeah,
yeah.
dang, this.
Hey, yeah, if anybody else wants to throw theirs up, that'll be fine.
Yep.
alright, there you go, now you can download it for yourself.
Okay. It's in the Discord?
Yeah, under SFML CPD.
What is it?
You should be able to just delete old chain and drag in this one, yeah?
Yeah, you should.
Into the preset?
Yeah, easy peasy. Has anybody else messed around with the code while I was talking and got something to show? I think most people were focused, I saw a lot of eyes.
I wish I could show it, but I have no parent I'm trying to figure out.
We got to move right.
Do that next.
His G over here. Dude. Ad hominem.
I don't know.
Midterms coming up,